Okay, here's a quick review of the Pythagorean theorem in a right triangle. You'll recognize a right triangle because it has one right angle. The square of the length of the hypotenuse equals the sum of the squares of the lengths of the legs. Or in other words, a squared plus b squared, that's the sum of the squares of the legs, is equal to c squared, which is the square of the hypotenuse. It's important to remember that c will always be the longest side in the triangle, which is the side that is opposite the right angle. So in example 1, we're asked to find the side length labeled t. So it's important that we identify the hypotenuse. That's going to be our c. So a and b don't matter which one is which. So t squared plus 6 squared is equal to 2 times the square root of 13 squared. 6 squared is 36, and 2 times the square root of 13 squared is 2 times the square root of 13 times 2 times the square root of 13, which is 4, that's 2 times the square root of 169, or 4 times 13 is 52. So t squared plus 36 is equal to 52. If we subtract 36 from both sides, we're going to get 16. And now we can solve this by taking the square root of both sides. That's going to give us t is equal to 4. If this were an algebraic equation, there would be two solutions, positive or negative 4, but since this is a side length of a triangle, we're only getting that one positive solution. But it is important to recognize that in algebra, you're going to have two solutions to that quadratic equation. In example 2, we're asked to find the value of n. So it's important again to recognize that right angle and the side opposite. So this is going to be our hypotenuse. So a squared plus b squared, that's n squared plus n squared, is equal to the square of the hypotenuse, which is 7 times the square root of 2 squared. N squared plus n squared is equal to 2 times n squared, and 7 times the square root of 2 squared is 7 times the square root of 2 times 7 times the square root of 2. And that's 49 times the square root of 4, or 49 times 2, which is 98. So we have 2 times n squared is equal to 98. Divide both sides by 2, and that'll give us n squared is equal to 49. And now we can take a square root. We're going to only use that positive solution, even though the quadratic equation will technically have two solutions, because n is the side length of a triangle, so it has to be positive, so n is positive 7. In example 3, we're going to find the length of the altitude, that's a fancy name for the height, of an equilateral triangle with a side length of 10. So first thing I'm going to do is just draw an equilateral triangle, which is one that has all sides equal lengths, and that's 10 and 10. And that altitude, or height, I'm going to draw in is going to hit that base of the triangle at a right angle. However, an equilateral triangle does something really special, and that is it divides that 10 side on the bottom into two equal pieces, each of length 5. So we're looking for that altitude, which I'm going to label h for height. And now if we recognize that we actually have a right triangle in here, Pythagorean theorem can only be used for a right triangle. In this right triangle, 10 is the length of the hypotenuse. So h squared plus 5 squared is equal to 10 squared. So h squared plus 25 is equal to 100. Subtract off 25, and that gives us h squared is equal to 75. So now we're going to take a square root, and we get h is equal to, and then we have to simplify that square root. There's a perfect square factor of 25. So square root of 75 can be rewritten as square root of 25 times the square root of 3. So that's 5 times the square root of 3 is the value of h, or the height of that equilateral triangle.